Hello everyone, welcome to Global Business Line. I'm Kunal Guha, Editor-in-Chief, and you are with me. And today here we have with us Raghunandan. He is the third generation entrepreneur and working very fantastically for his smart meters. So we will be discussing about all this today. So Mr. Raghunandan, welcome to Global Business Line.
Thank you, Kunal. Thank you.
So how you came into this entrepreneurship part? What's inspired you?
I think I was born into a family that has been in entrepreneurial line of work for two generations. I'm a third generation entrepreneur, and growing up, it's been really conditioned to get into this line of work, do something by yourself, start a business or join the business. Has been how I grew up. So there was never a question of finding a job or doing anything else. So that's how I find myself here.
Tell the story about the Konarak meters.
Konarak Meters, Venus Industries is the company that manufactures Konarak water meters. Konarak water meters is the brand that Venus Industries makes. And it was started in the year 2000 by my father.
Okay.
We actually got into this line of work because we used to make electrical meter components and car odometer components.
Okay.
And it was kind of a natural trajectory to get into this line of work.
Mm-hmm.
So Venus is the only company that makes its own brand. It's its own complete product.
Okay.
Whereas electrical meters and all that, these are components that we make for others. Water meters is our own brand. We, from scratch to finish, it is completely made in-house. We make the tools in-house. We mold all the plastic components in-house. We make the brass components in-house. Everything is made in-house, and it is the only product with our brand. Konarak is our brand.
Okay. So talking about the industry trends, how you got the particular idea for making it a smart, giving a smart, technology.
Right.
So today's generation, everything is smart.
That's true.
So how you got this particular?
So we have been making domestic meters for more than 25 years.
Mm-hmm.
And these were conventional meters that you physically manually have to go take the reading and note it down. So there's a lot of scope for human error. Usually, if it's a large scale deployment, there will be fudging of numbers. You cannot rely on the meter reader to give you the accurate results. So it was simply a natural progression for us to do this. We first started making GSM smart meters using SIM cards and GSM tech. About 7 years ago, we started this. And the issues with GSM was the battery would drain out, the signal would not be there all the time, and we would not get consistent data. Then we moved on to Bluetooth meters. The issue with that is it requires human. It's not fully smart and automated. It requires still human presence to go near the meter, within the range of the meter, take the reading, and then push it to the cloud. So that was still, not an adequate solution. Then we made Wi-Fi meters, which had its own limitations with the Wi-Fi signal and everything. So finally, what we are trying to push now is LoRaWAN water meters. So this tech, it kind of nullifies all the drawbacks of the previous, iterations of smart meters we had. It has a good battery life. It doesn't suffer from signal loss. It's able to consistently give the data, repeatedly every day. So this is how we ended up with this product. Basically, to solve the problem of physically going and taking the readings and make that whole process automated and error free, as well as giving consistent and accurate readings every day. So this is the product. This is
So
how
I want to know more about you. As a smart meter, it also helps in water conservation, right?
Yes.
As you are working on.
Yes.
So
So-
how is that working?
So any meter, not just smart meters, any meter. Metering is an old saying. Metering is the first step towards water conservation. So if you do not know how much water you're consuming, how will you know how much water you can save, or how will you know how much water is being wasted?
Yeah.
So the first step lies really in precise and accurate measurement of what you consumed, because that is the basis of the data that you have to say, okay, this is how much we consumed, this is how much we've pumped out, so this is how much is getting wasted. So this is where we must try to control the wastage, and this is how much we may end up trying to save. So it all begins with metering. Smart metering is the next step toward it, because you get real-time data. You don't have to wait a month to know that this much is your consumption. You don't have to wait so long to know that there's a leakage somewhere else. It's real time. The next day you will know, okay, there must be a leakage somewhere because this is not the right consumption, because you will have some metrics that you will be able to use in order to plan how to save water, try to pinpoint where the leaks may be. So you're getting the feedback loop is closed, and it is like a continuous, immediate feedback loop. So because of this, smart meters are more effective than conventional meters in probably being one aware of how much water you're consuming and how much water is being wasted. Otherwise, it would take a longer time for that cycle to finish. So that is the big part that smart meters will play in conservation of water.
So, as a you have been a long journey with this. So, as a MD, what are the challenges you have faced during when you are introducing this particular new product?
So the challenges we faced in the course of our journey, one, when we were trying to break into certain government tenders, there were a lot of entry barriers. Smart metering is water metering is a not such an easy business. The product that we have has to go through a lot of stringent tests and standards. So the standards are very high, and certain government utilities had certain certifications and standards that they required that we weren't complying before. And we took a look at what, and they were going with European makes and in foreign brands that had a certain level of quality that we were not able to match. So we took a good look at what makes them better than us, and we did good this thing of benchmarking and trying to understand how we can improve. Luckily for us, we have our own tool room, so we make all the molds ourselves. We scrapped all the old molds, went to a new generation of molds with a lot of the learnings and R&D that we did while studying where we were falling short and how we can make our meters more accurate to meet these standards of quality that is required by these government boards. And with a lot of it took about 4 or 5 years of good R&D. The tool making process is not easy. Like a lot of trial and error would go into getting the right component out of the tools. And once we did this, we were fairly confident that we were able to match this. We ended up sending our meters out to all the European labs to get them tested there and get the kind of standards that they pass. So at this point, after doing all this, we were the first Indian water meter company to get an MID standard, which is a Measurements Instrument Directive, which is basically a standard for European companies, European water measurement systems.
Okay.
And that standard is being used actually by a lot of good utilities in the country. So in order for us to supply that quality of meters and compete with these European counterparts, we had to go through that and really improve our quality. And we were now, and today we can confidently say, because now we have the same certifications as those European counterparts, we have the same quality, and head to head we can compare our meters in any lab, and we will get the same accurate results, and we will match, if not better, we will match the our rivals in foreign countries and foreign market. So this took a lot of effort into and understanding into how you make the meters more accurate and how you maintain this consistency in quality, because that's an ongoing and continuous process, quality and making sure all the components meet the tolerance that it has to for it to work. These are very delicate devices. They have to be assembled, tested, and everything
Even
in a
there
certain
will be
way.
some of the sensors and everything.
Yeah. So that way, it's not an easy thing to make. Not that easy to make the mechanical meters, at least. A quality one, that is. Anyone can make a water meter, but a highly accurate water meter that will work with the standards that these government bodies require is not simple. But at the same time, while we were focusing on these high-end clients that are very quality conscious, we were kind of neglecting the lower end meter market. So there is a scope for that also. And when we noticed, when we got back to ground reality, we realized there are a lot of different government schemes that are not so focused on high quality meters, but very cost effective meters that are required with a larger volume. So we realized we are losing ground over there. So and a lot of Chinese companies started to come in here. A lot of
That is what I was about to ask, because when you talk about any kind of manufacturing sector,
Correct,
there is a
correct.
big competition from the Chinese market.
Exactly. So not only do Chinese meters compete here, what they've cleverly done is there is a kind of inhibition for Indian people nowadays to buy Chinese products. So what they do is they go to different manufacturers themselves, Indian manufacturers themselves, and they sell them components. So the whole assembly is Chinese. They just white label their brand on many of these inferior products,
Yes, yes.
and they're sold because the cost is almost shockingly low to compete.
Yes.
So, and they are sold in this way. There's no testing, there's no calibration, there's no due diligence on quality that goes into this. They're just very focused on price. But we don't want to lose the market here. So what we ended up doing is we went back to the drawing board. We saw how we can try to reduce costs without compromising on quality. A large part of the cost comes in the brass of these bodies. So we thought, okay, how can we make this strong enough but also cost effective? And we created a new brand itself called Jal Jeevan brand.
Okay.
It is in line with the Jal Jeevan mission that you might have heard of. So the government today wants to make sure every house has a water connection. That is the aim of the Jal Jeevan mission.
It's like Har Ghar Nal.
Exactly,
Or Har Ghar Jal.
exactly. It's a part of. It's the same scheme.
Yeah.
So one of the names of it is Jal Jeevan. So with Jal Jeevan, we were able to trademark the name Jal Jeevan Meters also, and we created a new cost-effective brand that does not compromise on quality, will give the required specifications of what they need, and will give accurate readings precisely, consistently for a long period of time, so that we can try and compete. We are still not as cheap as the Chinese meters, but we are able to. The gap is not too high, and we are able to convince clients to go for this because our support is there. We have actually in the field about 50 lakh meters active today. So when customers know, okay, at the scale at which we are operating, they get some confidence that, okay, tomorrow anything, and these meters, most of them are under contract, so 5-year contracts, 7-year contracts. We are under maintenance of these meters. So we not only supply the meters,
who are your major, customer base?
Our major customers here in Bangalore is the BWSSB, Bangalore Water Sewerage Board, WATCO in Odisha, Delhi Jal Board in NCR region, and these are some of the major municipal bodies that we supply to.
Okay.
We supply to, in infra companies, we supply to L&T, SPML, and different large infra companies.
And any companies abroad?
Not at the moment, no. We, after getting now our European certifications and all that, we do intend to start exporting our meters.
Great.
But at the moment, no. We are working with some Japanese firms to try and export meters in Japan as well.
Definitely. That's great, no issue, because we reach to the each and every part of the Europe. So definitely, if you want to get into that market, this interview will take you there.
I hope so.
Okay, so you talk about much about the R&D part, the R&D process.
Correct.
So ultimately, leading that particular R&D part in the R&D process is a big headache, right? So how you see that? How you see that journey till now?
So luckily for me, I didn't have to do it alone. I have my mentor and my guru, who is also my partner, and my father, who works with me. And whatever ideas and innovations, anything that I wanted to do, has always been tempered, with his experience and with his insights and know-how. So with that way, we kind of balance each other. He's always rooted in very ground reality, and what can go wrong will go wrong sort of attitude, whereas I am more optimistic, and I can say we can reach higher than this. At the same time, we also have a very good team. We were able to search and find a good team that really is focused and driven to achieve the targets that we set and things we want to do. So not only do we make smart meters, development of the smart meters, we recently developed ultrasonic meters also ourselves. We do see that there may be a shift in the future from mechanical meters to more sophisticated ways of measuring water. So we feel ultrasonic meters will eventually become more prevalent in the way water is being measured. So we did a lot of R&D in developing our own ultrasonic meters. So we are ready with domestic sizes. We are working on bulk meter sizes.
This meter sounds like more of a kind of IoT completely based on. So okay, so what's the major challenge in that?
Now when we talk about IoT, an IoT meter it's the way it's going to communicate and the way it's going to share data.
Yeah.
So a mechanical meter can also be coupled with an IoT module, and it can become a smart meter. So a mechanical meter can also communicate data wirelessly in a smart way, and you can get the data on your phone real time. At the same time, you have ultrasonic meters too, but the way they work is a bit different. Like instead of how mechanical meters work is like there'll be a fan rotating and mechanical components over there that translate that to readings. Ultrasonic meters use ultrasonic waves to translate water consumption into signals and readings.
Okay.
So either way, IoT can work on both. You can have an ultrasonic IoT meter, you can have a mechanical IoT meter. Mechanical meters have their own advantages in the sense that it's far more cost effective to have a mechanical meter. You can have it's a large volume. You would probably want to go for a mechanical meter. If there's hard water and other things, it's better to go for mechanical meters. So ultrasonic, if you have a lot of dirt in the water, like if there's a lot of silt and stuff in the water, it may make sense for you to go for ultrasonic. So depending on the client and what they need, we will suggest the way forward, what tech to use. But IoT is the way it's going to communicate, and what we use is LoRaWAN. Okay. So we've frozen so far on LoRaWAN because it kind of balances the best of all worlds.
Yeah, that is what I was actually coming up. That if it is not that much confidential, can you just share what kind of technology you have used on this particular on your meters, every kind of meters? What you say?
Right. So, like I said, we started from GSM. We did Bluetooth meters. We have Wi-Fi meters still. For some apartments, it works out to have Wi-Fi meters. We also were the first Indian water meter company to make NB-IoT meters.
Okay.
We worked with Reliance for this. Okay. They have a GeoThings division that does its own IoT. So together with them, we developed an NB-IoT meter. This meter, it works extremely well. The main issue really is cost, because the SIMs and all that government utilities simply do not have the bandwidth to spare for high cost of the SIM maintenance of SIM and all that. So we feel a good solution so far will be LoRaWAN, and it balances everything like battery life, and we don't have high amounts of data that needs to be transmitted. It's in about a few KB really, the data that needs to go.
Okay. So, even technology, when you talk about the technology, it's completely changing day-to-day life.
Yeah, okay. Yeah.
How you keep your meters stay up to date? If your suppose if your data shared in Android or some updates are there, so how you completely manage it?
So now the software part of it, there's constant updates going on. Like exactly. As we grow, when we used to have only 200 installations, the bugs we had were very different. Now when we have about 2,000 installations, the kind of issues that we face are very different. 100%. So it's a trial and error. As we grow, we certain issues that we never thought would happen will happen or can happen. The software part of it is constantly changing. We're constantly updating that, and we're constantly revising it. With respect to hardware, we have a lot of foolproofs and safeties in place. We also make railway signal lights. Okay. We supply these lights to the railways. That gave us a lot of know-how on developing, fail-safe systems. A railway signal cannot fail.
Yes, exactly.
It can be catastrophic. So there are a lot of redundancies built into that system. So if something happens, next, it's going to always give a warning, or it's going to work in a way that it cannot fail. So in the same way, we've developed the electronics and the hardware in our smart meters also. So there are certain redundancies built in place. In case there's a failure, it shoots out a warning. It will try to work in another way and store the data at least, so the data won't be lost. And these kind of things, it's all trial and error. It's all from our previous experiences with different fields that we developed. And there's no correct permanent solution. It will keep changing. Tomorrow maybe NBIT or something else will come that may be cheaper and better, and we will be forced to upgrade ourselves, and this may become absolute. Who knows?
And how you measure the environmental impact through your meters?
So now, when it comes to a large scale, like in case we are talking about conventional meters that have conventional meters that are in government utilities, for example. Now in Bangalore alone, about 9 lakh meters are active. In Delhi, about 5 lakh meters are active. In Odisha, about 4.5 lakh meters are active. We have data and metrics from what the department gives us, so we know how much consumption is happening. and we know how many liters of water our meters are measuring actively. And these are meters that are under our care. For 5 years, we have to maintain them, we take care of them. So we know, in the field how much water is being consumed, and we are able to gauge how much water, they may be saving because they're getting the right data. Because our meters are, they are forced to work under very accurate conditions. So, if 1,000 liters of water has passed, the department is sure that 1,000 liters of water has passed within the error that that they agree to. So, they can be confident in the data that they are using, and when they publish a report, they know that, okay, when they take the readings from this and they publish large data, they know that, okay, these meters are accurate, and this is the amount of water we consume, and this is where we saved water, and this is how we reduce NRW. So when they say 15% NRW was reduced, non-revenue water was reduced, they can be sure that the 15% of non-revenue water will reduce, because they know the meters are working accurately. When it comes to like smaller scale installations, like in an apartment complex of, say, 100 numbers are there, 100 meters we've installed. They have an idea. The reason they buy water meters in the first place is because their borewell is dry. They don't have the Kaveri water connection, with the board connection. So they are using water tankers and stuff. So they already have a figure of how much they were spending before on water tankers, and taking into correction the price hikes of water. They are able to now give us, okay, this is the amount of money we save, because so much awareness happened when we installed smart meters. So much care happened into changing their mind on, okay, we cannot consume this much water on washing cars. They had certain rules they themselves put place, the apartment committee would put place, because they had accurate data coming in, and they had real time data coming in. So automatically, like, if one neighbor is using a hose on his car, the other neighbor will come and be like, hey, you can't do that. And that consciousness of using water starts to become more apparent in this smaller scale.
That will come under my next question, that how you see the water management. It's all the water management particular sector of that, and what are the main challenges you see and your meters are solving on it?
The main challenge that will take a while to solve is like this mindset that water is a fundamental right, that water is freely available, and I can consume how much ever I want. People have to understand that water is a very precious resource. It is also a very scarce. Fresh water is a very scarce resource. As Bangalore, very well experienced in the last summer, we had a terrible scarcity, and it really hit us. Ground reality set in that water is a scarce resource. It cannot be easily available, and it should not be taken for granted. The main challenge is changing that mindset, and in the middle, what happens is, since utilities and government agencies are directing this, water becomes a very political issue. So if one government, and Bangalore luckily is one of the few cities that is metering the water. There are many cities that don't meter water. Like, for example, Hyderabad doesn't meter water, Chennai doesn't meter water. Parts in the north, they don't really meter water. They give a huge tariff, 20,000 liters, 25,000 liters. So within that limit, water is free. So people don't have any value for that. They keep consuming it. They don't care. So the moment you start paying for every drop you use, that's when this conscious behavior of using water will set in, and that requires like a strong, political drive to say no. We cannot give freebies for water. It is valuable. It does cost us a lot of money to pump the water, filter the water, treat the water, and send it to your tap. It is not cheap. So that they're doing for free now, and that has to change. And that is the biggest challenge I feel with managing water. The moment that mindset changes, automatically everything else will fall in place.
If you can get something to change in your industry, what it would be?
The very same thing I just said. Like, if people start to see that water is not a free commodity, or not a readily available resource that can be used endlessly, that it is a finite resource, that it is an expensive resource, and it is a very precious resource, and it should be treated that way. If that mindset changes, I think everything else will be built around it. If you take example, we worked with some Israeli companies. I had the chance to go there. They're in a desert. They don't have any water. They fully realize, how valuable water is. They recycle 80% of their water. They made desalination plants and everything in order to have fresh water. So, that mindset they have on how to conserve water, if even, 50% of that comes to us, with all our resources, it will change completely the way water is being managed and what is being used. People certainly will not be wasting water while they're brushing their teeth or whatever it is. There will be certain habits that people will start to form, and that will impact the way the government also starts to politics also around water will change. They will not use water for vote banks, and that should be out of it. Water is a resource, and that is a precious commodity, and that should be accounted for completely. It cannot be a way to say like, okay,
Should not be a freebie.
it should not be something to change favor for votes and things like that. Because it should be treated with respect, and if that changes, automatically all the projects that they will undertake to give water and all that will be taken more seriously as well.
So you have worked with very many of the governments. You have worked with the private organizations. You have worked with institutes, large companies. You are supplying to them. What is the main thing you have saw that okay, this particular things is really good that we can adopt, and what would be that?
So certain boards, like for example, WATCO, BWSSB, they're kind of pioneers in their field. They were the first to kind of implement 100% metering wherever they give connection. They're the first to kind of put very stringent standards on having the right meters and being answerable to the higher authorities on the kind of quality meters that they're going to use. So setting those right standards, not being swayed by cost and anything else, and bearing in mind that high quality will give them accountability on their revenue. What they have realized is, in order for them to generate revenue, the thing that matters the most is the water meter. If this water meter is giving accurate reading, that means the bill is going to be accurate, and when the bill is accurate, they will be able to recover whatever they've invested into the water meters and into the infrastructure better, and they will be profitable, and they will be able to run the utility successfully and ensure that everybody is receiving water at the right time and adequate water. So they have followed really some of the best practices, and they are very keen to also start going to the next step. That is, they want to start avoiding all the human error in meter reading and all that. They do want to start getting into smart meters. They do want to create an AMI, automatic meter infrastructure around this setup that they already have, so that they will be able to get real-time feedback. They will be able to get understand where the leakage can be happening, where all water needs to be supplied, but it's not being supplied. So they are on the right track. They do have the idea that eventually they will do pilots, and that they, based on the success of the pilots, they will go for large scale installations, provided they have enough funds. So they are really like on the right track.
Okay. So any message for our viewers?
Save water, measure your water. That's all I can say. And metering is the first step towards water conservation.
Thank you so much. Thank you so much for your time.
Thank you.